Welcome to our physics lesson on viscosity. Today, we'll explore viscosity, an important property of fluids that affects how they flow. This is a topic covered in Class 11 Physics for CBSE and NIOS curricula. Viscosity is the property of a fluid that measures its resistance to deformation or flow. Think of honey versus water. Honey is more viscous than water, meaning it flows more slowly and resists motion more strongly. Viscosity arises from the internal friction between fluid molecules. As molecules in different layers of fluid move at different speeds, they exert forces on each other. Newton's law of viscosity states that the shear stress between layers of fluid is directly proportional to the velocity gradient. Mathematically, it's expressed as shear stress, tau, equals eta, the coefficient of viscosity, times dv by dy, where dv by dy is the velocity gradient perpendicular to the direction of flow. Let's break down this equation. Tau represents the shear stress, which is the force per unit area. Eta is the coefficient of viscosity, a property of the fluid. And dv by dy is how quickly the velocity changes across layers of fluid. The SI unit of viscosity is the Pascal second, pa-s, or Newton second per square meter, NES/m superscript 2. However, viscosity is often expressed in the CGS unit poise, P, where 1p equals 0.1 pa-s. The centipoise, Cp, is also commonly used, especially when describing water's viscosity, which is approximately 1 Cp at room temperature. Several factors affect a fluid's viscosity. First, temperature. For liquids, viscosity decreases as temperature increases. This is because higher temperatures give molecules more energy to overcome attractive forces. For example, honey flows much more easily when warm than when cold. Interestingly, for gases, viscosity actually increases with temperature. This is because molecular motion and collisions increase at higher temperatures. Second, pressure. For most liquids, viscosity increases slightly with pressure. For gases, viscosity is independent of pressure at moderate levels. Viscosity has numerous practical applications. In engineering, it's crucial for lubrication. Engine oils need to maintain appropriate viscosity across a range of temperatures. In medicine, blood viscosity is important for cardiovascular health. Abnormal blood viscosity can indicate various medical conditions. In food science, viscosity affects texture and mouthfeel. Think about the difference between water, juice, and smoothies. There are several methods to measure viscosity. The most common is using a viscometer. The Ostwald viscometer measures how long it takes a fluid to flow through a capillary tube. The longer it takes, the higher the viscosity. Another method is the falling sphere method. Here, we measure the terminal velocity of a sphere falling through the fluid. Using Stokes' law, we can calculate the viscosity. To summarize, viscosity is the property of a fluid that measures its resistance to flow. Newton's law of viscosity relates shear stress to the velocity gradient through the coefficient of viscosity. For liquids, viscosity decreases with temperature and slightly increases with pressure. For gases, viscosity increases with temperature. Understanding viscosity is essential in various fields, from engineering to medicine to food science. For your CBSE or NIOS exams, remember the key formulas and concepts we've covered today. Thank you for watching.